In this problem, our goal is to determine the angle between two tangent lines to a circle. From the problem statement, we see that both tangent lines intersect the y-axis at 2. We can approach this problem by considering the equation of a line in this form. Here m represents the gradient of the line. Our objective is to find the specific gradient values that result in the line intersecting the circle at exactly one point. To achieve this, we will use a mathematical tool known as the discriminant. The discriminant is derived from the quadratic formula and helps us determine the number of roots a quadratic equation will have. When a line intersects a circle at exactly one point, the discriminant of the resulting quadratic equation equals 0. This condition ensures that the quadratic equation yields a single solution. To begin, we substitute the line equation into the equation of the circle. This substitution eliminates one variable, and then after expanding and simplifying, we are left with a univariate quadratic equation. Then by collecting the coefficients of x, we can express the quadratic in the standard form. This form allows us to identify the coefficients a, b, and c needed to compute the discriminant. Since we are interested in finding the tangents, we set the discriminant equal to 0 and solve for the gradient m. After expanding and simplifying the expression, we obtain a quadratic equation in m. We can then solve this using the quadratic formula. And now, after many stages of simplification, as we initially expected, solving this quadratic yields two solutions, corresponding to the gradients of the two tangent lines touching the circle. These gradients allow us to write the equations of the tangent lines. To determine the angle between these tangent lines, we first consider the geometric interpretation of the gradients. The gradient m indicates that for every unit we move horizontally, we move m units vertically. This principle applies equally to the second line. Visually, we can interpret this as working with two separate right-angled triangles, which simplifies the process of calculating the angles. Before proceeding, it's important to clarify one detail. When calculating the angles, we should only consider the positive values for the vertical sides of these triangles. While the gradient can be positive or negative, we should disregard the sign when applying trigonometry. In this context, we want to find the angles located at the top of each triangle, which we will refer to as θ1 and θ2. Once we find these angles, note that simply adding them together will give us the desired angle. First, let's find the exact angle for θ1 using basic trigonometry. Now we will do the exact same thing to find θ2. Now that we have found both angles separately, the final step is to add them together, resulting in a theta of 92.4 degrees. Thank you for watching. If you have any questions, please feel free to leave them in the comment section below. And if you would approach this problem differently, I'd love to hear how. Let me know.